Okay, so today we're going to talk about a concept called molarity that we mentioned just a little bit yesterday. And our first blank here would be concentration. And that describes the amount of solute that's present in a certain amount of solution. Now we know the solute is what is dissolved in a solution, is present in a smaller amount. The solvent is present in a larger amount, and that's what does the dissolving. Now, a high concentration indicates a large amount of solute. It's more concentrated. A low concentration indicates a small amount of solute, and it would be more diluted. Now, label the solutions as high concentration or low concentration. If you notice this first one has the solute is the solid particles in there, so this would be the low concentration. And then the other one, since it has more solute particles, it would be more concentrated, so it would have a high concentration. Now next we have molarity, and that's used to measure the concentration of the solution, how concentrated it is. Higher the molarity, the more concentrated it is. The lower the molarity, the less concentrated it is. And molarity equals, we have an equation for this, equals moles of solute over liters of solvent. And we can, shorten that up by using a capital M for molarity, and that equals moles divided by liters of solution. Now, some problems will be given milliliters. We'll have to convert that to liters. And some problems will be given grams of our solute instead of moles, and we'll have to convert it to moles before we plug it into our equation here. But do know that if we talk about a solution and we just say that it's a, we see this right here, 3M. What that would mean is it has a molarity of 3 moles per liter, and we say that's a 3 molar solution, is how we describe that. Now if we look at some example problems. In every 5 liters of ocean water, there are 20 moles of NaCl. What is the molarity of NaCl in seawater? So what I like to do is go through and kind of underline the problem, what's, the numbers they give me. It tells me I have 5 liters. Now that's going to be of the solvent. And there's 20 moles of NaCl. And wants to know what is the molarity. So I'm going to start off with my equation, and it's a capital M. Molarity equals moles of solute over liters of solution. And I'm going to plug these in and then solve for the unknown. I'm just going to be using algebra. It's a very simple equation right here to work with. So I'm solving for molarity, so I'll just leave that as an M. That equals my number of moles, which is 20, over my liters of solution, which is 5. And then when I divide that, that would be 4. And then my units would be, it would be a 4 molar solution. Now, keep in mind, you'll always need moles, you always need liters of solution. And then sometimes you'll be given molarity in the problem and asked to solve for either moles or for liters. Okay, so if we look at some more, our next example problem, and by the way, these are the guided notes that you should have in front of you, this introduction to molarity ones. So a scientist collects 10 liters of salt water. Since we got 10 liters of solution, of the solvent, and 3.5 moles of NaCl. What's the molarity? So again, molarity equals moles over liters, and I plug in my molarity equals 3.5 moles over 10 liters. When you divide that, you'll get 0.35, and don't forget your units. Since we're solving molarity, it'd be a capital N, which means a 0.35 molar solution. And what that says, it means I got 0.35 moles of NaCl. If I was going to actually make this solution, I would take and weigh out 3.5 moles of NaCl. So I would multiply by the molar mass to get my grams of NaCl. I would weigh out that amount on a balance, put it in a container, and then fill it up with water to the 1 liter mark, and I would have a 0.35 molar solution. Or actually, I could make it if I had a 0.35 moles, I would add 0.35 moles of, I'd multiply by the molar mass of NaCl to get to grams, weigh it out, fill up the 1 liter mark, and I would have a solution then. And so it would be the strength of it. Now, what's the molarity solution that contains 1.9 moles of lithium fluoride dissolved in 16 liters of solution? Again, start my equation. Molarity equals moles over liters. So molarity is going to equal 1.9 divided by 16.0. I'm going to punch that into my calculator. So 1.9 divided by 16.0 equals, and I can round this to 2 decimal places like we always do. So that would be 0.12 and then a capital M, 0.12 molar solution of lithium fluoride. Okay, my next problem is how many moles of NaCl will be found in 2.6 liters with a molarity of 0.9 molar. I'm looking for moles. In this case, again, I start with my equation. Moles equals moles over liters. In this case, for molarity, it tells me that it's 0.9, and that's going to equal. And for moles, when I do this, I'm going to put an X in for moles just because I'm used to doing algebra solving for X. That's my unknown. My liters is 2.6. And then when I get to this, it's just an algebra problem to find my moles. I would need to multiply both sides by 2.6. They cancel on this side. So I get to this point, I'll take 0.9 times 2.6. And it gives me 2.34, and my units would be moles. And I abbreviate it. I'll leave the E off. It's just on habit. And then my answer would be moles of NaCl if I was going to be specific about this. Now next, how many moles of sulfuric acid, so I'm looking for moles, will be needed to create 8.5 liters of an acidic solution with a molarity of 3 molar. Alright, so again, start with my equation. M equals moles over liters. My molarity, it tells me, was 3.0. That equals, I'm looking for moles, that's going to be my X, and 8.5 liters. To solve for X, I need to multiply both sides by 8.5. So that would be 3.0 times 8.5, and that's 25.5. And my units would be moles. So next, number 5, tells me a scientist pours a concentrated solution of 10 molar, so it's giving me the molarity, 10 molar hydrochloric acid. If the solution contains 3.75 moles of HCl, what is the volume in liters of the solution? Alright, so again, I start with my equation. M equals moles over liters. My molarity in this case is 10.0, and that equals, my moles is 3.75, and I do that over, and my liters is my unknown I'm solving for, so I'm going to put an X in there. Alright, and now when I get to this point, I'll get to this point right here. I'm going to make it a little easier on me to solve for this. I could multiply both sides by X and then divide, to solve for X. But what I like to do when I have this part right here is put that over 1 and then cross multiply. So cross multiply and I get 10.0 X equals 3.75. And then I'll just need to divide both sides by 10.0 to solve for X. So that's 3.75 divided by 10. And I get 0.375 that I can round up to 0.38 liters. And that's my units. So that's a really simple equation to work with, but these problems get just a little bit more difficult, not much more. So if we look at some other examples, and these are advanced problems right here. You can use the equation for molarity to complete the problems below. Now ask me in the first one, what is the molarity? So that is my unknown, so it's asking me to solve for, of a solution that contains 16.5 grams of sodium chloride dissolved in 1.5 liters of water. Well, see, I have a problem in this case because my molarity equation tells me that I need moles over liters, and I don't have moles. Instead, I have 16.5 grams of NaCl, and I need moles of NaCl. So how am I going to do that? I just find the molar mass of NaCl, and by now I hope we all know how to find the molar mass. We've been doing these problems for 2 months. I add up the individual masses of NaCl, add them together, and I've already calculated that to make the video shorter, and I assume all of you know how to do this by now. And when I'm going from grams to moles, remember I divide I divide by the molar mass, so that would be divided by the molar mass, which is 58.44. So when I get to this point, that'd be 16.5 divided by 58.44. And I can round this answer to 2 decimal places, so that would equal 0.28. So that's going to be 0.28 moles of NaCl, and I can plug that in now to my equation. I got M equals moles per liter. So when I plug that in, that will become molarity equals my moles, which is 0.28, divided by my liters, which is 1.5. So when I do this, I get 0.28 divided by 1.5, and I get 0.186. That would round up, so my molarity would equal 0.19, rounded 2 decimal places. My units for molarity is a capital M. That means I have 0.19 moles per 1 liter. So my first step, if I'm given grams, I got to convert to moles before I can plug it into my equation. So let's look at another one. A scientist creates a solution by dissolving 25.22 grams of lithium fluoride. It has to give me the formula because I got to know what molar mass to calculate. And then it gives me 2.2 liters of water. What would the molarity be? All right, so I'm starting off. I got grams. I need to convert to moles. So I'm going to take 22.55 grams of lithium fluoride. I'm going to divide by the molar mass of lithium fluoride. So you need to add that up, look up the individual atomic masses and add them together. And I've already done that, and that's 25.94. So when I bring up my calculator, that's 20, actually it's 25.22. I think I wrote that down wrong. I need to correct that. So that would be 25.22. So 25.22 divided by 25.94. That's going to give me, rounded to 2 decimal places, that would give me 0.97. So that's going to be 0.97. And now I'm in moles of lithium fluoride. Then I'm going to take my equation, my molarity equation. Molarity equals moles divided by liters. I'm going to plug in some molarity now. It's going to equal 0.97 divided by my liters, which was 2.2. And that's going to give me an answer around 2 decimal places of 0.44. And that would be, my units would be a capital M for molar. So that would be a 0.44 molar solution, which would be 0.44 moles of lithium fluoride per 1 liter of solution. Okay, so my next problem. A scientist wants to create 0.5 liters of calcium chloride solution so it's giving me the volume there in liters of calcium chloride solution with a molarity of 4.0 molar. And it's asking how many grams of CaCl2 would be needed to create this. Well, if I'm asked for grams to solve these problems, well then my equation tells me that molarity is equal to moles divided by liters. First I need to solve for moles, and then for moles I can figure out the number of grams by multiplying by the molar mass. So first I'm going to plug in and solve for my moles. So it tells me my molarity is 4.0. And that equals my moles. I'm going to put an X in there over the liters, which is 0.5. And when I solve for X, I will need to multiply both sides by 0.5. It gets rid of it on this side. Then my X is going to be my moles. So 4.0 times 0.5 would be 2.0. And now I'm in moles. But I need my answer in grams of CaCl2. So I'm going to take CaCl2, add up the molar mass of it. When you add it up, you would get 110.98. And to go from moles to grams, if you remember, we multiply. So I need to multiply by the molar mass. And that gives me 221.96. .96. My units would be grams. And that would really be grams of CaCl2. So if I'm given grams in the beginning, I have to convert it to moles for it to work in my equation. If I'm asked to solve for grams, I have to first find my moles using my molarity equation and then multiply by the molar mass to get the grams. Okay, our last problem here is how many grams of silver nitrate would be needed if a scientist wanted to create 4.5 liters of 0.25 silver nitrate solution. Alright, so it's telling me that I want to know how many grams something is, and my volume is 4.5 liters, and the molarity is 0.25 molar. Again, if I'm asked for grams, first I have to use my equation to solve for moles. So when I plug that in, my molarity, it told me, was 0.25. My moles, I'm going to put an X in there because I got to solve for it first, over my volume, which is 4.5 liters. To solve for X, I need to multiply both sides by 4.5. And that's going to give me 0.25 times 4.5. And I'm going to round this to 2 decimal places. That would be 1.13. And now I've just found moles of AgNO3. So to convert that to grams, I need to find the molar mass of AgNO3, add up silver's atomic mass, nitrogen's atomic mass, and 3 times the molar mass of oxygen. When you add those up, all those up, you would get the molar mass to be 169.87. To go from moles to grams, I'm going to multiply by the molar mass. And my answer to 2 decimal places will be 191.95, and that would be grams. Alright, now those problems are pretty easy. That equation's easy to work with. The last thing that we need to talk about, because none of these examples had this, but I think in the worksheet that you'll run into this, sometimes you'll be given your volume, and I would write this down somewhere on your page. You'll be given your volume in milliliters. If that is the case, you need to convert that to liters, because you have to be in liters. And the way you do that is by dividing by 1,000. If you remember from early in the year, the King Henry died by drinking chocolate milk. You go from milliliters to liters, you're moving 3 places to the left, so you move your decimal 3 places left. So you either can punch in your calculator and divide by 1,000, or simply move your decimal 3 places to the left. So let's say in a problem, I'm given 500 milliliters as a volume. I cannot work the problem with that. I need to be in liters, so to convert that, I'm simply going to move my decimal. And there's no decimal in there, so it would be at the end. I'd either divide 500 by 1,000, or put my decimal in there at the end and then move it over 1, 2, 3 places. And that would equal 0.5 liters. So I need to make that conversion before I work the problem. Say I was given another example. I was given a volume of 1.45 milliliters. I will need to convert that to liters. Again, you could divide 1.45 by 1,000, or you simply can move your decimal 3 places to the left, which would be 1, 2, 3. Put in your zeros, and that becomes 0.00145 liters. So make sure to read the problem carefully. If you're given milliliters, change it to liters. Divide by 1,000 or move 3 places to the left. All right, so, and as a review, our equation for molarity is moles of solute divided by liters of solution. I can solve, plug in whatever to do, solve for my unknown. If I'm asked, if I'm given grams in the beginning, I would need to convert that to moles by dividing by the molar mass of whatever substance it is. Or if I'm asked to solve for grams, I would need to use my equation to solve for moles. Then I would need to convert that to grams by multiplying by the molar mass. Remember, if you're doing a conversion, if you're going grams to moles, your moles should always be less than your grams. If you're going moles to grams, grams is always going to be bigger than moles, so you should know to multiply by molar mass. Alright, so now your assignment is to complete the molarity worksheet number 1. And we'll come back and do some more of these problems in about a week.